So here we go. Question 36 about turning points and roots. And there's a little bit of a question at the end about whether you can spot a pattern and why that pattern might exist. So here's the question. We're looking at quadratics, cubics, and quartics. And we're looking at the minimum maximum number of turning points and the minimum and maximum number of roots. So all quadratic equations, when we graph them, are parabolas, and they're depending on whether the coefficient of x squared is positive or negative, we either get the green or the red line. We must have one turning point, but we can't have more than one turning point. And the minimum number of roots, well, if we take the green line, if the x-axis is below the green line, then there are no roots. You can get one single root, or we call it repeated roots, but the maximum number of roots is 2. Cubic equations, though, have got more variety. We might have any one of these 6 types of cubic graphs to look at, and you may have a single turning point here, 2 turning points here, or the orange graphs have got no turning points at all. So the minimum number of turning points on a cubic is 0, but the maximum is 2. We can have 1 as well. Now, wherever the x-axis is, the x-axis is up there or there, then the cubic must cross the x-axis at least once. So the minimum number of roots is 1. We can get 2 points where the graph cuts the x-axis like this, 1 there and 1 there. We can get 3 points where it cuts the x-axis, 1, 2, 3, but that's the maximum. So the maximum number of roots is 3. With quartics, however, we've got a rather bigger variety of different shapes we can look at. So a variety of different shapes for a quartic here. The ones at the 5 at the top here are when the coefficient of x to the power 4 is positive, and the ones below where x to the power 4 is negative. The number of turning points, if we look at turning points first, here we've got 1 turning point, and here we've got 1 turning point. Here we've got 2 turning points, and with these graphs here we've got 3 turning points. You can't have less than 1 turning point. There must be at least 1 turning point with a quartic, and you can have up to 3 turning points. What about the roots now? If we look at the graphs at the bottom, if the x-axis was down here, let's say, you might get 2 roots. If it was up here, you'd get no roots. Can you get more than 2 roots? Well, yes, you can. You can get, in this case, if I draw that carefully, you can get, if that was up a little bit, you could get 4 roots. Can you get 3 roots? Can you get 3 roots? Yes, you can. 1, 2, 3. So you can get no roots, or 1 or 2 or 3 or 4, but that's the maximum. So that's the answer to the question. But the budding mathematicians among you may be saying to yourself, well, that's interesting. I wonder if there's a pattern here. and there is a pattern. I'm going to leave you to think about that on your own. And also, if you can spot the pattern, you might be interested to think about the question, well, why? Why is that pattern as it is? Think about that for a while as well. Okay, if you got the answer to the question the same as I did, then well done. And have a think about those other two questions as well.